Great. Thank you guys for showing up. This is a full packed house. My name is Jonathan Kelly. I'm joined here with Evan Almoff. He's our core maintainer and also head of AI. So he's an AI wizard, I guarantee you. So it's going to be a fun presentation. We're going to show you how Dioxis is using AI and large language models to fundamentally rethink the future of app development, which sounds grandeur, of course, but we actually think it's pretty interesting. We're solving problems for ourselves. We're not solving problems for other people. So without further ado, let's get into it. So if you don't know, Evan and I maintain Dioxis. So it's an open source library for building cross-platform apps with the Rust programming language. Seems like everybody knows what Rust is, so we don't have to go too much into detail. But Dioxis, much like React Native and Flutter, makes it possible for developers to build apps that work across web, desktop, and mobile with a single code base. So you're not rewriting an app for Windows and Mac and Linux. You build it once, it ships everywhere. Today we support Mac, Windows, Linux, Android, and iOS. So we've got very wide platform support. We have nearly 20,000 stars on GitHub. We have several popular projects, Taffy, Blitz, Dioxis itself, and it's used by both small startups, we have lots of small startups, and a couple big organizations like Airbus and the European Space Agency. So some familiar faces. Building a new app with Dioxis is pretty easy as far as getting set up with cross-platform app development. We ship a command line tool called DX. We love developer experience, DX. Simply call DX new, choose your platform, DX serve, and you're up and running. So a new app compiles from scratch in less than 12 seconds. We care about compile times. The code for a Dioxis app intentionally looks very similar to a React app. Here's our code sample. Hopefully you've seen some React in your lifetime. We did this because we didn't want developers to learn anything new beyond Rust. The most popular UI framework on Earth right now seems to be React. And if we want people to use Dioxis, we can't make it too different than what people already know. Thanks to Rust, Dioxis apps are end-to-end type safe. So you can build a front end and a back end that share types across the boundaries. It's insanely fast and portable across nearly every platform and architecture. So because Dioxis apps can run natively, they're not in a virtual machine or a sandbox, they can directly leverage platform APIs like multi-threading, Bluetooth, and geolocation, unlocking a whole new class of apps that would be very difficult to build with React Native or Flutter. You'd have to create language bindings. You'd have to hop through virtual machine interfaces. With Rust, we can just call those system APIs. So while Dioxis is becoming increasingly popular, we generally hear 3 complaints from our community. We're always listening. The first primary complaint, Dioxis has a much smaller ecosystem than React. Obviously, it's growing, but Dioxis is younger than React. It's 2 years old. React has been around for more than a decade at this point. And React has a lot of momentum. If there's some obscure package you need, usually React ecosystem has it, whereas in Dioxis, we have to get a community member to volunteer to build and maintain it. Number 2 is Rust can be challenging, especially for newbies. So if you don't know the best patterns and architectures, especially for UI, you'll be slowed down when building Dioxis apps and Rust apps. And number 3, which we focus a lot on, is Rust has slower iteration cycles than JavaScript. Typically, JavaScript code can be reinterpreted on the fly. You can edit a JavaScript function, send it to the Chrome V8 runtime, and it gets reloaded in place. With Rust, you have to satisfy the borrow checker, and the app has to be recompiled. Now, the borrow checker is very good for complex code. If it compiles, it usually works. But UI code tends to be simpler. So fast iteration is generally more important than whole correctness. So our primary goal right now for Dioxis is to increase developer productivity. If you can build faster with things like hot reloading, auto-formatting, bundling, and signals, you can ship faster. And when projects get shipped, the ecosystem gains more libraries, docs, and examples, which feeds back into developer productivity. So the faster we can help developers ship new apps and iterate on the apps, the bigger the ecosystem will grow. And that's where we're exploring this generative AI angle. So we have 3 main things we want to do to make building with Dioxis faster. Number one, we want to decrease the amount of boilerplate code you have to write. We've done a lot of cutting boilerplate code throughout the library. It used to be very verbose. Things are a lot simpler now. We've made a lot of changes. But still, if you want to build a header or a nav bar, you're writing code you've probably written 100 times before. We want to improve the reliability of not only Dioxis, but people's apps when they go to build Dioxis. So we don't want these apps to be fragile. We want people to be able to ship quickly and not run into annoying bugs and errors as they're building. And then number three, we want to shorten iteration cycles. So going from idea to what's on the screen to you want to tweak it back into the code base, we want that to be as quick as possible. When you're really in the flow, you can build much faster than if you're sitting there waiting for recompiles and having to figure out what Tailwind classes do what. So this is where AI comes in. We believe, both of us, are very enthusiastic about this whole AI revolution that's coming and taking the world. We are a little bit less optimistic on the AGI part of it at the moment. Maybe we'll get there. But we actually think it could be very useful for the next generation of app development frameworks. And you're starting to see this with companies like Vercel. They're shipping their new v0.dev. Like, this is a tool that helps you iterate on UIs quicker. If you can be an open source framework and provide these accelerated copilots for your framework, people will be able to pick up, learn faster, and ship faster. So today, we're showcasing our own fine-tuned LLM specifically for Dioxis, basically a Dioxis copilot, capable of autonomously building, testing, and iterating on your apps exclusively for Dioxis. Our work is all open source, so there's a link at the end you can go explore, and it runs on commodity hardware. So you actually don't need to set up any servers. If you have a decently beefy MacBook Pro, you can run the Llama 7B model, and if you have a less powerful model, a computer, you can run our smaller Phi-based, like fine-tuned model, which is still a work in progress, but it's there. When we think about what a perfect Dioxis copilot would be, before we write any single line of code, we kind of like design the problem space. So what I'd want out of a Dioxis copilot is something that helped me build and improve the actual visual UI with very little friction. I'm not much of a designer. Our apps look pretty terrible when we go to build them. So we want that iteration to be as frictionless as possible. Number two, we want to automatically perform quality assurance in testing on our apps. If an AI can write tests for the component I just built, a date picker works or a calendar system works the way it should, or the page just renders what we want it to render, right? We don't want a login page rendering a logout button. We'd be able to iterate faster as well. And number three, we want to modify code that we've already written in place. So we're going to have to write our own code at some point. And we want to be able to improve things like accessibility or layout or styling or content. We want to be able to iterate on these things in place after we've already written them. And if you really think about it, if you built a copilot for your framework, for your library, for your favorite tool, like, the world is your oyster. There's like so many things you could do. So automatic refactors, like turning components into multiple components or merging components, improving accessibility. So, the 10% of people who need screen readers, they're now included in the party. Adding new pages, auto-generating forms, all like the boring stuff that you have to like do to plumb apps together. You could automate that with like a tailor-designed LLM. And we actually run into this a lot. So this is like some of the apps Evan has built and some of the apps I've built. We shipped a really stupid bug when we updated our documentation. It only works in dark mode, so it's just like transparent, and we didn't catch that for like 2 weeks. And we're just inundated with stuff like this, right? Because it's hard to run a large open source project and pay really close attention to these details. Without further ado, Evan.
All right. So when we were creating this project, one of our requirements was making this run on commodity hardware. There's a couple different reasons we wanted to target commodity hardware instead of running this in the cloud. First, local models are getting pretty good. They can generate code that is almost as good as Llama 70B, and with fine-tuning, much better. Next, we don't want to run any servers, just because it helps us iterate faster. We can ship code to you faster, and you guys can give us feedback faster, which just will help us make the product better. And it also makes it easier to contribute to if there's not a server running. You can just download our repository and do cargo run, you're done. Local AI is also crucial to making the code generation private. and helping with offline development. If you're on a plane ride, you don't want to reach out to the cloud every single time you generate a component, and we don't want you to have to send us or your code to us. All right. So part of the problem we want to solve is turning your prompts into code. And let's take a look at how models today do this. So there's a lot of potential for automatic UI generation. It's great for small teams because you can use AI to generate a component library for your project, help you iterate on styles and layout, and generate mock data to present your application to investors or other stakeholders. It helps you automate boring and tedious UI code like forms and login flows. So first, let's start with the most obvious question. Can the best open source models today generate Dioxis code? The answer is not really. You can kind of see it try to generate some Dioxis code there, but it doesn't actually compile, because that is not our syntax. Attributes in Dioxis should be inside of the curly braces, not outside of it. And even if we give it more context about what RSX is and how you use it, it doesn't do a great job. We have a bunch of examples we can feed into the LLM, but even with in-context learning, it fails. But the good news is, these models have been trained on a bunch of HTML, and they can generate pretty good HTML. So you can see over there, there's a website generated with Llama 7db, and part of what we've worked on for tooling with Dioxis is turning that HTML into RSX. So we can use the HTML generation capabilities of the Llama models and generate RSX code with it. While Llama 7db does a pretty good job at generating HTML, it definitely lacks in some places. It doesn't always follow the format we give it, so we want it to generate components with placeholders for us to fill in, and sometimes it generates JavaScript alongside that, which is difficult to convert to RSX. It generates components that are never used or used incorrectly, and it generates SVGs that look like nothing. So as you can imagine, LLMs are not very good at spatial reasoning, so they don't generate images very well. And even with the Llama 7db model, we get a correct output like 20% of the time, and that output is usable like 10%. But there's good news. We can use fine-tuning to improve the performance of these models significantly. Specifically, we're going to be using LoRa fine-tuning, which is low-rake adaptation. It lets you fine-tune a small bit of the model to tweak how it works. And we can fine-tune the model using a large data set of optimized prompts. But the issue is, how do we find those prompts? There's a whole bunch of projects using Dioxis on GitHub, but a lot of those projects are not well documented, and we don't have prompts of like what each component does in those projects. We can solve this by generating a synthetic data set. So instead of training on Dioxis code we see out in the wild, we're going to be creating our own code with Dioxis and training on that to produce better results. There are a couple different steps to synthetic data generation. First, you're going to generate prompts and responses, filter out the bad responses, and then run a response optimizer to make those responses more consistent and smaller so they're quicker to generate. Finally, we're going to save the optimized prompts and responses and adjust the weights using LoRa fine-tuning. So after we've generated our prompts and responses, we need to filter out subpar responses. A bunch of the responses we get from the Llama 7db model are not actually valid code. So we can check if we can parse the output, if the component will actually compile, and if it answers all the questions we ask about the UI. Make sure all the components are used, and then see if there are any problematic elements. This helps us filter out low-quality responses from the baseline model, which will help us to generate a better data set to fine-tune our smaller model. After we have a data set of prompts that work, we can optimize the responses with normalization. This helps us turn a bunch of different responses that all do the same thing into one consistent format that will be easier for our smaller language model to learn. And then for performance, we can turn all of the responses into a smaller format that will be quicker to generate. So as you can see on the left-hand side, the larger model generated a very large prompt, but we can condense that into a smaller response with the same content. In total, we generated about 1,000 prompts prompts and responses from the Llama 70B model. Only about 8,000 of those followed our format, and only 1,500 actually passed our quality filters. We used LoRa fine-tuning to fine-tune the model, and even though we used an 8 billion parameter model instead of a 70 billion parameter model, the output generation quality jumped by a factor of 2, and we now get an output that's pretty good 20% of the time instead of 10. So now that we have a model that performs well for UI generation, we need a way to run the model. This is where a library I worked on called Kalosm comes in. Kalosm makes it easy to run quantized models on commodity hardware like this laptop. You can run quantized text, audio, and image models. It uses constraint generation to let you filter the output of the model to make sure it follows a format you give it. And it has integrations for context extraction and databases to make it easy to use the model with your data. I mentioned context or structure generation in the previous slide. This lets us make sure that the output of the model follows the format we give it. Small models are especially prone to hallucinations and runaway generations, which means they just generate on forever. Structure generation lets us programmatically influence the output of the model depending on the state of a parser we give it, like an HTML parser or a regular expression. Traditional LLMs take the text you give it and try to predict the next token by generating a series of probabilities. With constraint generation, we take those probabilities and we filter out all the ones that don't fit our format. So here, if we generate the components list and we're starting the list, it thinks we want to keep generating text, when really what we want is to start a list. So we can mess with the probabilities and have it generate a list, and it can continue generating from there and see what is probable next. So constraint generation helps our problem significantly. The base model was not very good at following our prompts, but the smaller model can follow our prompt exactly with constraint generation. And this improves our format accuracy from like 20% to 90%. It almost always follows the format we give it, where it generates components and then HTML, and finally the HTML for our top level component. The only reason this isn't like 100% accuracy is because sometimes there are places where the model can run on and still run into issues with infinite generation. All right, so we have a demo prepared for today. We're going to be creating a component that does,
You need to do the mirror displays.
yeah. We're going to be generating some cards for a website that has information about Dioxis. So we wrote a little CLI. Eventually, hopefully, this will be integrated into the Dioxis CLI and VS Code extension. But for now, it's generating different components that it thinks it needs for this application. And you can see some Dioxis code output with RSX that is generated. And if we run this code, we can see a couple cards about Dioxis that respond to the current device. So if we make it smaller, you can see the layout changes automatically, and all of the CSS is responsive. Along with generating UI, we would also like to work on verifying the UI we create is correct and readable. And this is where agents come in. So agents are language models combined with actions. So you can take instructions about the task, constraints to follow a consistent format, and context from the environment to ground the model, and turn it into an agent that takes input, takes an action, and produces a result. One example of this you might see is something that can search the internet. But for this case, we're going to be using constraint generation to verify your UI is correct. So we can use a very small language model for this, because all we're doing is checking if some change is consistent. And even small language models like Phi3 can understand HTML pretty well, even if they're not great at writing it. So Dioxis knows what elements are interactive, and we can use this information to generate a list of actions we can take on your page. And once we take those actions, we could feed it to the LLM to perform the action in a headless browser, diff the result with the LLM to see if the response is consistent, and then classify it to see if, yes, this is consistent, or no, we need to flag this and have a developer check it out. And this example is running the Kalosm agent, the Dioxis quality assurance agent on the Dioxis homepage, and checking between tabs on our examples to make sure that when we click those examples, the output is correct. So it read the HTML from the headless browser and saw what changed. Now it is looking at the HTML and seeing if the change it saw is consistent with the action it took. So if I clicked on like the server button, does it actually show me code related to using a server with Dioxis? Even though this is a smaller model, it is generating a lot more text, so it takes a little bit longer to run. We can come back to that demo at the end if you want to take over.
How long does it take?
It should take like, yeah,
Oh,
okay, here it is. Yeah, so it'll generate a whole bunch of reports like that. We can come back to that at the end if we have time.
Cool. Yeah, so there's some other interesting stuff we can do when we have the ability to run local models or operate on your code base. With the same large language model that we've like fine-tuned, we can also apply like changes in place. So, for example, we can add accessibility attributes, like ARIA attributes to existing parts of your code base. So if you just built your app, you didn't really care about accessibility, and then you're like, I want to ship it, you would run it through the Kalosm agent. It would tell you your app's not accessible. You could do this in CI. If you want access to a larger model, you could do this locally. Obviously, we have plans to speed up the generation. And then we'd actually be able to suggest edits in the form of like a pull request or local suggestions that would say, hey, we've identified these places in the code base. Maybe you want to add some accessibility attributes, and that would make this component work with screen readers. We can also do the same thing for like anything you can imagine. So you forget to add dark mode, like that one example in the beginning of the slide, you could add dark mode just as easily. I mean, and there's so much you can do. You can do theming, you can generate variants of components. We support hot reloading, so we could actually pipeline like 10 components at once and give you 10 different options of a component that you've seen, and then be able to modify your code base in place with those previews. So there's a lot you could do with in-place LLMs. And the context is a lot smaller here, so we're only feeding in just the single component. The other interesting thing that this allows us to do is things like suggested refactors. So in our corpus of data that we pass through the fine-tuning, we can take, like, say, a very large component and suggest smart ways of breaking it up. So if it sees like a header, list, and a footer, it would actually be able to identify those types of components through RAG or just the fine-tuning that it's seen before, and then give you a VS Code automatic inlay like suggestion, like these things, if you use VS Code, that would automatically split the component up, pull this data apart, and these sort of complicated refactors that would have been hard before are now done all with the context inside the editor. And there's like a ton of other stuff, especially relevant to Dioxis. One common pattern when you're doing React type state management is hoisting state. So you have state inside of a component that needs to be shared between a bunch of other components. We'd be able to do an automatic refactor that pulled that state up and then shared it with the neighbor components. If you do that yourself, that takes like 5 minutes, sometimes 10 minutes, sometimes an hour if like there's a lot going on. We'd be able to do that instantly. So again, shaving those seconds off as you're doing these fast iterations. We can move state to like from global state into context. If you're building libraries, you need to libraryify your app. You know, you're building a bunch of complex components. You want to share that with people. You'd be able to run an automatic refactor that made that easy to publish. We could organize project files. I mean, there's just so much you could do when you're able to modify code bases in place. So what's next? Well, one, performance, obviously. Commodity hardware, fewer tokens is interesting to explore, and retokenizing. So right now, a like div tag in HTML is like 6 different tokens. When we're operating on abstract syntax trees, that's 1 token. So we can make it, you know, there's a theoretical limit to how fast we can make it, but we can make it much faster. We want to be able to ship this to like the Dioxis users as sort of a add-on experimental feature. We have dev tools planned for the next couple releases, and we're adding more interesting bits of functionality, and we're planning on shipping a more fine-tuned version of Phi 3 in that. That would be fast and lightweight that anyone could download and start using. We want to add interactive UI generation, so like a drag and drop type editor or like Figma style thing that uses background generation to give you variants of the app and let you choose what you like. That way you're not writing Tailwind classes, you're just seeing what the options are and then choosing the one you like. Automated UX testing. So the agent did some interesting stuff, but there's more things we could do. We could tell you if like your user experience is bad, or your pages don't look right, or it doesn't like the color scheme, or there's like weird formatting and layout issues. We'd actually be able to analyze that with the OCR capabilities of Kalosm and give you suggestions to fix that. And then extracting this out as just a generic implementation for non-Dioxis code. A lot of this is generalizable. We need to run this in CI anyway. Every time we release a new version of Dioxis, the old fine-tuned model is now kind of irrelevant. And then ship it to production. So yeah, that's it. You can see all the work it's on GitHub. It's on our Dioxis Labs page. Yeah, thank you guys.
You want to check out your demo or no? You want to check it out? See if yay.
Yeah.
Yay.
So you can see, like, now that the demo has finished, it notified like a couple different buttons that didn't work. So in the bottom half of the screen, you can see, like, I intentionally messed up the page so we can see the demo working. And if you click on the server.rs button, it says the new functionality is not aligned with the typical UI marketing site's purpose or user expectations. It seems more like an example downloading a asynchronous Rust programming rather than actual server-related content, which is true. It swapped it with the async Rust example, and the agent caught it.
Okay. Any question for Jonathan or Alan? Come on, this is a future unicorn. You got to have questions. Yeah, okay.
What's your profit model? Or just doing this from the kindness of your heart for the open source community and everything?
It's a good question. Right now, it's more of a make Dioxis as amazing as possible. I mean, compete with Flutter, right? Like, what is it? Flutter has 100 core engineers. It's just hard to compete with these things if you're trying to like extract money out of these dev tools. So honestly, we just want to make Dioxis great right now. I think long term, Flutter has Firebase. There's Supabase out there. There's an appetite for hosted services. You can make money that way. I think it's the point here is to break down all the walled gardens between Apple and Android and all these different platforms. And so there's value to be captured there. And it's a very honest business, I think. Just like host code, package managers, all that sort of stuff. Yeah.
So next question is, are you hiring?
Yeah. Not very quickly, but we are hiring.
I get the idea of why you want to run it locally from the perspective of being able to code offline, not having to host your own servers, those sorts of things. But is there also an intent to try and keep it safe from the public world, from keeping your code private, for example, like why not host it in the cloud environment?
Yeah, so privacy I think is a big thing. That's one of the reasons I originally built Kalosm is there's a lot of these local AI hardware startups coming out. So you see like the Humane AI Pen and Rabbit, and those have a lot of data you don't really want to get out. And they mitigate that right now by like opting into recording. So in each of those, you have like a button you press that records your surroundings. If all of this was local, you could theoretically do that like without sending any of it to the cloud. And it's kind of the same situation here. You don't have to send any of your Dioxis code that might have like your secrets or API keys or company like information to us, so you don't even have to trust us.
So you don't have to, so why should you?
Yeah.
And kind of for what it's worth, if you pulled out a GTX 4090, you generate tokens 10 times faster. And if you like plug our stuff into Grok, I think it's like 100 times faster or something. You know, it's truly instant, right? Yeah.
Yeah,
So the transformation from HTML to your language, that's just normal code, or can you use AI models to also help with that? Is it just, you know, a regular expression or HTML parser with a generator?
Yeah, right now it's HTML parser and then generate RSX from that, and it just generates RSX for like the easily parsable parts of the code. So you know, like the element names and the attribute names and then the values. For more complex things like closures, we would like to eventually like use AI with some combination of like hard-coded stuff. So there's like some functions that are really easy to translate, but then there's some that are more difficult. Like some structural changes might be necessary to translate all JavaScript functions or closures into Rust. So it's definitely an area we'd like to like improve on in the future.
Right. I'm going to steal this stuff, man.
Any more questions? Oh, okay.
Yeah, thanks. This was awesome. I see you have the VS Code extension. Have you considered if it would be possible to use, for example, like LSP to get the code editing into different editors?
In theory, it should be. We don't today. We don't implement a full LSP. It's a lot of work to maintain those, but you know, it's coming soon. I don't see why we couldn't stuff a lot of this generation behind the LSP. So those like inlay hints, you actually have to be an LSP to provide those. So we want to provide those, and we're going to have to become an LSP to do that. And in that case, you would be able to use that LSP in any editor. So you know, Vim, Helix, or whatever. So yeah, you can do all this in a normal editor.
Thanks.
Yeah.
Okay, any more questions? Oh, right. Yeah, okay.
So have you noticed any significant differences between like Phi and Llama 3? And I mean, you've been doing this for a while. What is the vector on the models compared?
One thing I've noticed about Llama 3, like Llama 3 8 billion, is it follows prompts a whole lot better than Phi, but it also runs a whole lot slower. So Phi is good at things where you can use constraint generation easily to make it follow like the instructions you're giving it. But if you can't do that and you have something that's harder to constrain, then Llama 8B is better because it can follow the like, system prompt you give it to tell it like what to do.
And if you compare it to the 70B model, is there a significant difference, or?
Yeah, the 70B model generates code a lot better, but you can use like fine-tuning on the 70B model to get a similar performance, especially if you have like a very specific use case.
Okay.
Okay, any more? Oh, right there. See, this is, the last one is the finale. We get a lot of interest here.
Yeah, so you're restricting the output based on what's valid characters. Couldn't you use that to basically force the language model to output DSX directly instead of HTML? Because it gets close, but not all the way there. So if you restrict the output to valid syntax, wouldn't that make it so that you don't have to use the HTML generation, parser, everything?
Yeah, so that's one of the things we like to explore in the future is generating RSX directly. Right now we have to go through HTML because these models are already trained on a lot of HTML, and we don't have that much RSX as training data. We do have like quite a bit of fine-tuning data. We have like 1,000 examples
10,000.
about, well, 1,500 that actually passed our filters. If we had a whole lot more, fine-tuning on just RSX would work, and that would theoretically like save us some tokens because you don't have to generate end tags for everything. But at that point, we could also explore tokenizing this differently so that it doesn't matter what syntax of HTML-like thing you're generating.
And also for this demo, we like just restricted the number of components to be 3, which is what you see 3 on the screen. We can just pull that limit off as well, right? Yeah. So, but that corpus of data would be much bigger, more complicated. We actually trained we trained some of this on like our own laptops, and then some of it on what, a T4.
Yeah, it was like a mix of T4 and A100.
Yeah. So to generate RSX directly, we probably need like way more computing power for the fine-tuning stuff. Yeah. It was free to fine-tune, by the way. So, yeah.
So the question was, how long did you fine-tune?
Yeah, how much effort did it take to fine-tune the model?
There were a couple different runs as we got more data, but it took like an hour on a T100 to fine-tune using QLoRa. And that was with like 5 epochs through our training set. I don't know that. I'm not sure off the top of my head. I think it was like under 16 gigabytes, but other than that, I don't know.
Probably. You could probably do it on if you have a big enough rig.
There's
Yeah.
a project called Axolotl that does like fine-tuning locally that you could look at. We didn't use it, but it's an option.
Okay, any more? Oh, we got one more.
I'm not too familiar with the project. It seems to me that the point of it is to generate a functional prototype of UI or a startup point that you can start to iterate on. Do you also have ideas on generating the UI in terms of theme or like in terms of prettiness, like something that functions like a concept in terms of the aesthetic design?
Yeah, so that's kind of where the closed loop comes in. Once we get the testing code working really well, we can theoretically use that to take the code we output, test that, and make sure it actually looks good and has like a user interface that makes sense, and then use, if it looks good, to filter the output again. And then either use that for generating a more high quality synthetic data set that looks a lot nicer. As you can see, like it works. It does like respond to changes in the screen size, but it doesn't look fantastic. So generating code that looks better and UI that looks better is definitely something we'd like to look into more in the future.
Yeah, and what's kind of interesting is there's a lot of component libraries out there for like Tailwind, probably thousands of components of good documented Tailwind components that would actually serve as like a good like aesthetic benchmark that we can use to, again, fine tune.